Okay, honors, this is concept 3, computations involving function notation. This is actually take 2. I was like just starting this video when a helicopter decided to pass by and it was really loud, so I just decided to start all over. Um, the notation f of x is read f of x. You guys know this, right? F of x is a notation of a function that actually represents y. What this is saying is, remember in your algebra 1, right, your equations used to be y is equal to whatever that equation was, and then they told you that you can also have f of x is equal to whatever that equation is. This is just function notation. It just means that it's a neat way of writing when you want to evaluate the equation. So in other words, y is equal to f of x is the same thing, except one again denotes to evaluate functions for x. Let's consider the function f of x is equal to -2 times x plus 3 squared plus 4. This is a quadratic, it's in vertex form. Find each of the following function values. So what I did here is I just plugged in f of -4. I plugged in -4 here, and then figured what that was, and I got 2. Right here, f of -1, and I got -4. Here I plugged in 0, and then I got -14. So the first one here says when you find the values, when you find the value of f of -4, that's the first one. The value of x equal to -4, we got 2. So what does the result of -4 represent graphically? Okay, f of -4 is equal to 2 means graphically that when x is equal to -4, y is equal to 2, or the point would be -4 comma 2. Okay, this means, again, just showing it graphically here. Okay, this graph here is the one that's up here. Okay, so when you're at -4, you get +2. It would be a point on the graph. Okay, that's what evaluation means, right? And every single time I graphed, especially the previous 2 concepts, and of course all of last year, that's what we mean by when you take each point, when you evaluate each point and you get some result. Okay, it's a point on the graph. So right here says the graph of f of x is pictured to the right. Do the results of f of -1 and f of 0, that would be the next 2 up here, okay, do the results of those 2 calculated above make sense in the context of the graph? Explain why or why not. Okay, so notice that for f of -1, I got -4. So here's f, here's -1 for x, whoops, hang on, here's -1 for x, and I got -4. So it's this point there. For f of 0, I got -14. That's going to be, it's actually out of frame. Okay, but doesn't mean doesn't make sense in the context of graph. They do, in the sense that, let's see, f of -1 is equal to -4 means when x is equal to -1, y is equal to -4. This does make, we already showed it, right? This makes sense graphically because, I'm going to abbreviate that, BC, because the point -1 comma -4 is on the graph of f of x. Okay, we already showed it. F of 0 is equal to -14. Whoops, let me see, -14. That's the one that was out of frame, right? But notice that when x is equal to 0, okay, when you evaluate a function when x is equal to 0, what you're finding is where the graph would, because again x is 0, you're finding where the graph would intercept the y-axis. Okay, it's your y-intercept, in other words. So f of 0 equals to -14 is the y-intercept of the graph. I mean, according to the graph they gave us, yeah, it does make sense. We'll say it's possible. It's possible according to the graph. Yeah, it's possible according to the graph, as it's a negative out of, we'll call it just like out of frame, I suppose. Okay, that's it. Okay, so that's just writing mathematics. It's just describing what's going on. The next one says the graph of f of x has two zeros. Remember from algebra 2 what a zero of a function is, and define that term below. Okay, a zero of a function, a solution, right? Or more importantly, the interpretation they're looking for here is a zero of a function is an x value where the graph crosses or touches, if you remember your polynomial functions, the x-axis. Okay, in other words, your x-intercept. Okay, that's another way to write it. So semicolon x-intercepts. Okay, the graph of f of x clearly crosses the x-axis at a value between x is equal to -4 and -1. So here's -1, here's -4, right? They give you these two because those are the ones we evaluated here on top. Okay, right here and right here. We know for a fact that the graph crosses right here in between -1 and -4, right there. Okay, based on your computations above, how would you justify the guarantee of this occurring at some value between x is equal to -4 and -1? So using the computations we have here on top, we have 3. Okay, in particular we're taking 2, the -1 and the -4. How can we use that information to guarantee that the graph of f of x crosses the x-axis between those values? Okay, so we have f of -4 is equal to 2. Okay, so at -4 we got 2, and f of -1 we got -4. So again, at -4 we got 2, at -1 we got -4. Okay, that means, okay, so these two means that the graph goes from above the x-axis, right? Because again, f of -4, you're on top, you're in the positive y's. Okay, when you go to f of -1, you're now in the negative, you're below the x-axis. So the graph goes from above the x-axis to below the x-axis, because of the change, the change of signs of the y-coordinates. The y-coordinates or the y values, right? Those are the ones we got here, the 2 and the -4. So we went from the top above the x-axis to the bottom. That means this graph, well, how do you go from the top to the bottom? This graph has to therefore cross the x-axis. Okay, that's how you use your computations to justify that there is a zero between those two values. Okay, So I mean, you can expand on that a bit and say this logic, right, this forces a 0, this forces a, I'm running out of space here, a 0 to exist between x is equal to -4 and x is equal to -1. Okay, based on the graph, we cannot determine exactly what the zeros of the function are. Notice that it's crossing again in between two integers, so it's kind of hard to really say what they are, right? Or just looking at them graphically. According to the graph, between what pairs of x values do the zeros of the function lie? Now this we could estimate, right? There's definitely one. So we have between, right? Let's take the first one. Between, well, this would be the first one reading left to right. Between -4 and -5, right? Between x is equal to -5 and -4, and between, right, we took that one, -1 and -2. Well, -2 and -1, because I'm reading left to right. Oh, sorry. Okay, so between -5 and -4, and between x is equal to -2 and -1. Okay, those are the two whole numbers or integers, right, where we know for sure there are zeros to this function. Okay, so whoops, that's not the next thing. Here's the next one. We have, on the previous page, we took the function f of x, right? That's the one we worked with, and found values of y by substituting in the x values. Now suppose we set the equation f of x is equal to a and solve for x instead. For f of x, solve each of the following equations. So what this is you have the function, set it equal to 0. Okay, so notice that this first one, setting something equal to 0, right, your y is equal to 0, that's going to be along the x-axis, which means this first one here, this first computation, will find the solutions to this quadratic. So you have negative, let me give myself some space, -2 x plus 3 squared plus 4 is equal to 0. Okay, and I just solve. Subtract 4 from both sides. I get -2 x plus 3 squared is equal to -4. I divide by -2, so I get x plus 3 squared is equal to +2, right? Because I divided by a negative, and then take the square root. So this is solved by square roots, if you remember those quadratics. Okay, so you have x plus 3 is equal to the square root of 2, and then subtract 3 from both sides. So x is equal to, and remember that this is got the square root, right? So you have plus or minus square root of 2 minus 3. So let's get what those values are, those decimal values. So you have positive square root of 2 minus 3, and you get negative. So x is equal to -1.586, and then the other one would be negative square root of 2 minus 3. If you do this one, you're going to get -4.414. Okay, so these are the solutions we got. So these are the actual x-intercepts of the graph we saw earlier. Okay, for the other one, I think this one just takes yeah, it's just f of x equal to -4. So let's find for what x will you get -4. Okay, so -2 x plus 3 squared plus 4 is equal to -4. Subtract 4 from both sides. You'll get -2 x plus 3 squared is equal to -8. divide by -2, you're going to get x plus 3 squared is equal to positive 4. Take the square root of both sides, you get x plus 3 is equal to square root of 4, right? You'll get 2 plus or minus, and then you'll get x is equal to plus or minus 2 minus 3. So positive 2 minus 3, you get x is equal to -1. X is equal to -2 minus 3, you're going to get -5. So these are the two values, okay? And this makes sense if you look on, actually, you know what? I think it's graphed right here as well for us. This makes sense because at -1, we do have -4 right there. And then at -5, here's x, -5, we also have -4, okay? So there are two values for x in which your y would be -4. So I think that's what the next question. No, it's not. Okay, so it says when you solve the equation for f of x is equal to 0, what do the results for x represent graphically? Does this concur with what you concluded about these special values on the page before? Okay, so the results, we already talked about this a bit back, right? The results of f of x is equal to 0 represent the x values when y is equal to 0. These are the zeros of f of x. The next one says explain how your results for x when you solve for f of x is equal to -4 above concur with the graph of f of x pictured to the right. Oh yeah, that's what we just said, right? So, well, not just, but just before what the previous question. When f of x is equal to -4, then x is equal to -1 and x is equal to -5, which means the points -1 comma -4, right? -1 comma -4 right here, and -5 comma -4, which is right here, must be on the graph of f of x. Okay, and they are. They're right there. In summary, when you evaluate f of a, what does the result represent graphically? Okay, f of a, so if you have f of a, represents the y value when x is equal to a. You plug in a into the function, you get some y value. So you have points, right? So these are whoops, misspelled r. These are points on the graph. Oh, sorry, I didn't even realize I was out of frame there. These are points on the graph. Okay. In summary, when you solve the equation f of x is equal to a, what do or does the result or results represent graphically? The results of f of x, f of x is equal to a are, so this is like what we were just doing up here in these two computations, okay? So the results of f of x equal to a are the x values when y is equal to a. Okay, so it's like working backwards. Okay, so one more page, I believe. So it says for each of the following, use the given function to either I think so, it's supposed to say either find the y value given the x value or the x values given the y value. Use the equation but verify your algebraic results using the given graph. Okay, so for the first one I have this absolute value equation, absolute value function, and here's the function that goes with it. Okay, so I have the equation and the graph. It says find the value of g of -6. Okay, so it's just evaluating g of -6. Okay, g of -6 is equal to -6 plus 2. I'm just plugging in -5. This is absolute value of -4 minus 5. Absolute value of -4 will be +4 minus 5, and that's equal to -1. So remember, this means that this would be a point on the graph. So -6 right here, I should get -1 for y, and yeah, it's a point on the graph. Okay, that's what they mean by verify using the given graph. Okay, the next one is g of 1, same thing, just plug in. So I have 1 plus 2 minus 5. I get absolute value of 3 minus 5, which is 3 minus 5, which is -2. So again, this is a point on the graph. So when x is equal to 1, y should be -2, and it is. Here's a point on the graph. Okay. For what values of x does g of x is equal to -4? Now you can just, if you've really understood the lesson, right, you can just work backwards. Y is equal to -4. So here's -4. Sorry, -4. So y is -4 here. And notice that there are 2 points in which y would be -4. So these would be the answers to this question. Okay, it would be at x is equal to -3 and -1. So that's one way to do it, just by given the graph. If this was an ACT questions or college entrance exam, you'd be done. You'd be able to select the possible options there, or the correct option. But how do you do this algebraically? Recall how to solve absolute value equations. Okay, so I wrote the function here, and I know it's equal to -4, so I have to solve for x. Okay, an absolute value function. Remember, you isolate the absolute value. I added 5 to both sides there. Okay, make sure I make these a little more pronounced. Okay, and then you're gonna have, remember, you split it, x plus 2 is equal to -1, or x plus 2 is equal to 1, and you solve 2. So x is equal to -3, and x is equal to -1. Okay, and these are the two, just like we said, right, the two x values in which y is equal to -4 according to this graph. So you have one there and one there. Alright, for what values of x does g of x is equal to 5? So same thing, what you just did. X plus 2, absolute value -5 is equal to 5. Add 5 to both sides, you get x plus 2 is equal to 10. Then split it, you have x plus 2 is equal to -10, or x plus 2 is equal to +10. So x is equal to -12, or x is equal to 8. Okay, that's it. And of course, verify on the graph. So where's y is equal to 5? Actually, oh, you know, it's out of frame. So right, +5. +5 is going to be somewhere up here, and because it goes both ways, right? That means that for some x value over here, eventually you're going to be up on 5. Okay, and that would be -12 on the negative side, and then +8, x is equal to 8 on the positive side here, somewhere up here. Okay. Moving on to the last one here, same idea what we just did, except now we have a radical function that's been reflected over the x-axis, right? Shifted to the left 6, and then shifted up, right, up 3. Okay, and this is the resulting image. So it says find the value of h of -1. So it's just plugging in. So h of -1 is equal to -2, square root of -1 plus 6, and then plus 3. This gives me -2 square root of 5 plus 3, and then unfortunately, yeah, I'm gonna have to use my calculator for this. So -2 times square root of 5 plus 3. I'm getting negative 1.472. So that means when x is -1, y is -1.1472. So it'll be about this point here. Okay, and that makes sense. The next one will be, that's it for this one. The next one is h of 10. So plug in 10, I get -2 square root of 10 plus 6 plus 3. Okay, that's equal to -2 square root of 16 plus 3. You get -2 times 4 plus 3, and this is -8 plus 3, which is -5. So when x is 10, it's unfortunately out of frame. You're gonna have -5, so somewhere over here. Okay. For what values of x does h of x equal to 1? So where y is +1, so they're looking for this one here. Okay, so this is actually one of the neat ones where the graph crosses a lattice point, so you can actually see that when y is equal to 1, x should be right here, when y is equal to 1, x should be -5. So let's verify that. So -2 square root of x plus 6 plus 3 is equal to 1. So we'll solve for x, right? Subtract 3 from both sides. I have -2 square root of x plus 6 is equal to -2. Then I divide by -2. I'm going to get square root of x plus 6 is equal to 1. To cancel out the square root, I'm going to raise both sides to the second power. Okay, so I get x plus 6 is equal to 1 squared, which is just 1. And then I subtract 6 from both sides, and I get x is equal to -5. And we just shown it algebraically and graphically, okay, that when h of x is when you have h of 5, that's equal to 1. -5, that's equal to 1. Okay, last one. We have for what values of x does h of x equal -3? Here's -3. It's going to be, it looks like it would be when x is 3. So let's verify that. Same way we just did. -2. You have x plus 6 plus 3 is equal to -3. Subtract 3 from both sides. I get -2 square root of x plus 6 is equal to -6. Divide both sides by -2, so I get square root of x plus 6 is equal to 3. Raise both sides to the second power, you'll get x plus 6, cancels out the square root, that's equal to 9. And then I subtract 6 from both sides, and I'll get x is equal to 3. Okay, and it does, right? Just like we said, it does look like that's where you'll have the function equal -3. Okay, that's it. That wraps up concept 3. Okay, ask me questions if you found any of this confusing, but hopefully you'll be fine.